Hello, welcome to the NPTEL certification course on deep learning. So in today we are going to introduce the content of this course, and we are going to talk about that what all we will be covering in this lecture series on deep learning. So the topics that I will cover is, obviously the first one is an introduction to deep learning. Then we will talk about that when we learn something, how do we learn, in the sense that we learn certain properties or certain features or certain descriptors using which we recognize an event or we recognize an object. So we are going to have a brief introduction to what are descriptors or what are feature vectors. Following that, we will talk about what is machine learning and what is deep learning. Machine learning is the traditional approach, and how we are differing when we are going for deep learning, what is the difference between machine learning and deep learning. Then coming to deep learning again, we will talk about two different models of deep learning. One of them is the discriminative model and the other one is the generative model. Then we will see that what are the challenges of deep learning applications when we want to have any application of the deep learning techniques, what are the challenges that we face and how we try to mitigate those challenges. And then we will briefly talk about that what is the power of deep learning techniques or what we can do using deep learning methods. So first, let us try to see that what is learning, or then we'll come to what is machine learning. So to talk about what is learning, I'll show you these two pictures, or you take any picture for that matter, or even a word, say father. So coming to these two pictures, I'll simply ask you, can you recognize these two pictures? The answer will be obviously yes. All of you hopefully will say that the picture on the left is a cave painting in Ajanta caves, and picture on the right is the picture of Parliament building in New Delhi. Okay, so we have been able to recognize these two pictures, or we'll be able to recognize thousands of such pictures which are shown to us, or we'll be able to understand thousands of words which we will hear, or thousands of sentences we will hear. But the question is, we have been able to understand we have been able to recognize these two pictures, that is fine. But the question is, how do you recognize it? So you find that when we look at any of these two pictures, obviously, how do I recognize that the picture on the left is Ajanta, is a painting from Ajanta caves? The reason is, either my parents, my friends, they have shown me that these are the paintings from Ajanta cave. If not, maybe I have visited Ajanta cave and there I have seen this painting, or maybe I have seen these paintings in textbooks, in history books, right? In most of the history books, such paintings, images of such paintings are abundant. So I have, while seeing those pictures, I have unknowingly, unintentionally tried to capture certain properties or certain descriptors from this picture. And using those properties or those pictures, I have built a model which is embedded in my brain. So next time, whenever this painting is shown to me, I try to find out similar descriptors or similar features, and I try to match those features with the model that that is embedded in my brain. That means this picture is associated with an a priori knowledge that I have, right? So using that a priori knowledge, I try to recognize, or I can recognize this picture very easily. But suppose the picture on the right That has never been shown to me. I have never seen Parliament building, or I have never seen an image of Parliament building. Nobody has shown me, nobody has told me. So if this picture on the right is shown to me, I'll probably say, okay, this is some building because I know the buildings look like this. But I'll not be able to say that this is Parliament building because that association I don't have. So how do you recognize, or how do you get the description or the features of any event or any object or any picture? We'll try to see through this course. So again, come back to learning. Let us see what is the origin of machine learning. The origin of machine learning, or the origin of learning as such, is nothing new. This lies in very early efforts in trying to understand what is intelligence. So an intelligence can be defined as that it is the ability to comprehend, to understand, and profit from experience. So you find that this definition is very, very crisp definition. And these three words, comprehend, understand, and profit from experience, these three lies at the heart of what is machine learning or what is deep learning. Or in other words, we can also say that the intelligence is the capability to acquire and apply knowledge. So we are experiencing various events every day, each and every day. We are watching new objects every day, and through that we are acquiring knowledge. And then what we are trying to do is we are applying the knowledge that we have acquired through experience, and that is what is intelligence. So coming back, it is almost 2300 years ago, or even more than that, the great philosopher Plato, who was there during the period 427 to 347 BC, he brought the concept that the abstract ideas are known to us a priori through a mystic connection with the world. So you note what Plato said, that it's a mystic connection with the world. So the abstract ideas are known to us a priori. And of course, this makes sense, because otherwise, how is it possible that a newly born baby can easily recognize his or her mother, right? So definitely it is something mystic connection with the world. And Plato concluded that ability to think is found in a priori knowledge of the concepts, right? So everything is, as per Plato, everything is a priori. So does it mean that we don't learn anything new? So that was something which was missing in what Plato said more than 2300 years ago. But soon after, it was actually Plato's pupil, Plato's student, who brought in the concept of learning. He pointed out, Aristotle pointed out, that in Plato's concept, a very important aspect was missing, that is, ability to learn or adapt to changing world. So all of you know that every day, as we experience new and new events, as we see new and new things, we are learning continuously. So learning is a never ending process. Every day we are learning something new. Okay. So that is what has been introduced by Plato. That is what has been introduced by Aristotle, who was Plato's student. So coming back again to the machine learning, or when we try to recognize something, when we learn some object or some animal or some word, how do we learn it? Let us come to this. So either we see an object or an image of an object, or maybe we listen to some words, to some sentences every day. So when we talk about say machine learning or deep learning, a very important application of this deep learning or machine learning is being able to understand or recognize objects that we see or the images that we see, or being able to understand or comprehend the sentences that we hear. See, when someone says go to school, I know that what does that sentence mean, go to school. So that means we understand it. Okay. So coming to the machine, when the machine is to learn and the machine is to deliver, then obviously these sentences or these images are to be converted into a form which the machine will understand. So come to a picture which is shown on the left. Apparently it is a picture of a cat. All these pictures are actually represented by two-dimensional arrays of numerical values, and mostly those are integer values. So those of you who know about the digital images, you know that we talk about pixels, we talk about megapixels, 18 megapixel, 40 megapixel, 50 megapixel and so on, which are actually the power of the camera that we have. So these pixels are nothing but an element in a two-dimensional array or an element in a matrix. So any image is represented as a two-dimensional matrix, which is as shown over here. So this is a two-dimensional matrix which is part of the image which is shown on the left. And every element in this matrix is normally an integer value, and you know that these integer values are 8-bit integer values. That means every element in the image, every element in this matrix can assume a value from 0 to 255. And that is true for a black and white image or a gray level image which does not have any color information. But if I have a color image, the color image is represented in two planes, the red plane, green plane and blue plane, and each of these planes can be considered as a grayscale image, and every pixel in such grayscale images are again 8-bit quantized. That means coming to a color image, every pixel in a color image will have three components, the red component, blue component and green component, and each of these components can take values from 0 to 255. That means every pixel in a color image is represented by 24 bits, 8-bit per color component. So that is how an image is represented in a computer. Similarly, when it comes to word recognition or voice recognition or speech recognition, then the speech signals are to be represented digitally. So what is shown on the right hand side is what you get from the output of a microphone. You know that microphone converts an acoustic signal, which is a voice signal or any other sound input, into an electrical form and then into an electrical waveform. So this is the snapshot of an waveform which is output of a microphone, and this you get when you utter a pair of words, say news items. Then the microphone output will be something like this. And now if we sample these outputs and digitize each of the samples, what we get is a time series, a sequence of samples in time. Okay. So this is how a voice signal or a speech signal or a sound signal can be represented in a computer. So once I have these representations, next is how do we process these informations so that this processed information can be used by a computer for understanding or for recognizing. So for that, what we need are the descriptors or the feature vectors. So here I am showing you two different pictures. One is the picture of a horse, the other one is the picture of a zebra. Now, given those two pictures, you find that both of them has got two types of properties. One is the shape property, other one is the region property. So what is the shape property? Let us come to the next picture. If I simply take the boundary of a horse or the boundary of a zebra, what we get is shape of these two animals. And here you find that the shapes of these two animals are almost similar. So, by looking at the shape only, possibly I will not be able to say which one is horse or which one is zebra, right. But maybe that using this shape information, I will be able to say that, okay, this is either a horse or a zebra, it is not a bird. Okay. So, this is the kind of information that I will be possibly be generated, I will be able to generate given the shape information, that this might be a horse or a zebra, but definitely this is not a bird. But to distinguish between horse and zebra, what I need is the additional information. That is, what is the property of the region bounded within this boundary. So, if you look at on the left where I have a horse or on the right where I have a zebra, in case of a horse, the color of the bounded region and the texture of the bounded region is totally different from the color and texture of the bounded region corresponding to a zebra. So, in case of a zebra, I have black and white stripes, which usually I do not have in case of a horse. So, if I want to distinguish between a horse and a zebra, or given an image, if one I have to recognize that which is the image of a horse or which is the image of a zebra, then possibly I will make use of this information, both the shape information as well as the region information or the region properties, which will help me to identify that which figure is the figure of a horse or which figure is the figure of a zebra. So, we need both these kind of informations, the shape information and the boundary information. There are different shape informations possible. So, given a shape, I will have multiple informations, because I may have to distinguish one shape from other. So, I have to distinguish a rectangle from a circle. So, the shape information of a rectangle and the shape information of a circle will not be same, they will be different. And this discrimination can be done using multiple number of properties. It may not be possible that I will have a single property. This has to be done using multiple number of properties. Similarly, when I go for color, again from the color I can extract multiple number of properties. Similarly, when I go for texture I can extract multiple number of properties. And each of these properties, if I can represent in the form of numerical values, then you concatenate all these properties together, right. Say from shape, if I extract 5 properties, then the shape information can be represented by a vector having 5 elements. Similarly, color, from the color, if I extract 10 properties or 10 descriptors describing a color, all those 10 descriptors putting together gives me a vector having 10 number of elements. Similarly, for texture, again I can have 10 number of elements. So, if I concatenate all of them together, I get a total 25 elements. So, that means a bounded shape, a bounded region is described by 25 features or by a feature vector having 25 elements. Now, using these feature vectors, I can go for identification or classification of the objects or classification of the bounded region, whether the bounded region corresponds to a horse or it corresponds to a zebra or it corresponds to a bird. If it is a bird, what kind of bird, and all these detailed classification can be made once I compute these descriptors or features. So, the first level of understanding or learning is to find out the features. So, once I have these features, then let us talk about what is machine learning. And when I talk about the machine learning, then I will come to deep learning. So, for that, let me try to find out, let me see that what is machine learning, right. So, what you have obtained so far, given an object or given an image. So, given an image or an object, the image is converted into a set of vectors, into a set of features, where the features collected together is forming a feature vector f. So, you find that if I have say 25 such features, or I have a feature vector having 25 elements, then this image is represented by a vector or by a point in a 25 dimensional feature space. Now, for simplicity, let me assume that this f is actually a 2-dimensional feature vector for simplicity. Obviously, a shape cannot be represented by, or any image cannot be represented by 2-dimensional feature vector accurately, but for simplicity I am doing this. So, if I have this 2-dimensional feature vector, let me put this feature vector feature components as component f1 and component f2. So, f1 f2 gives you a feature vector. Now, if I have images of horse, they will form a point distribution somewhere over here, say in my 2-dimensional space. Similarly, if I have images of zebras, they are very similar, right? So, they can have a set of point cloud somewhere over here. But if I have images of say apples, and I compute the same similar feature vector, similar features f1 and f2 for apples, they may form a set of points somewhere over here. Now, why this distribution? The distribution is because every apple is not identical, every horse is not identical, every zebra is not identical. So, for all those different pictures, when I compute f1 and f2, they will not always give me unique values, but there will be a variation. And because of this, I get distribution of these feature vectors. Now, what is the advantage of having such a kind of distribution? The advantage is advantage of having such a kind of feature vectors or descriptors. The advantage is the moment I have a feature vector, that means my image is now represented by a point in the feature space. And given 2 points in the feature space, if I find that the distance between the 2 points is very large, I can immediately say that these 2 images are not similar, they are different. But given 2 points like this, where the distance is very small, I can immediately say that these 2 images or these 2 objects are similar. So, that is what you get, the advantage that you get when I represent these as feature vectors. Now, given an image, I can have different types of feature vectors, as I said, the shape, color, texture, and many other features. Given an image, I can directly compute a vector from that. So, an image is typically of size m by n, which has got m number of rows and n number of columns. One way of vectorization is you take every column from this image. So, I get one column having n number of elements. Then I take the second column having again n number of number of elements and concatenate with this. So, first here I have the first column, that is first m number of elements. Here I have the second column, second m number of elements, and so on, and that way continue and concatenate with this the last column. So, you find that this entire image of size m by n is now converted to an 1-dimensional vector, where this vector has m into n number of elements. So, this whole image is now represented by a single vector. Now, coming to what is the difference between our conventional machine learning and the deep learning. In case of conventional machine learning techniques, what used to be that you decide that what are the features or what are the descriptors that are to be extracted from the input signal, whether shape features, color features, texture features, and what are those features. So, accordingly, you have a pre-processing technique, and this pre-processing technique gives you the feature vectors. And these feature vectors are inputted to your machine learning algorithms. And for that, we can have different types of machine learning algorithms, statistical machine learning like Bayes rules, Bayes classification rules. I can have linear or nonlinear classifier. I can have support vector machines. We'll talk about each of these in our later lectures. So I can have different types of classifiers. Even I can have neural networks as classifiers. So these feature vectors are inputted to those classification algorithms or machine learning algorithms. And for training the machine learning algorithm or for training the classifier, what you do is you feed a large number of feature vectors taken from known objects. That means the feature vectors, I know that from which object or from which class that feature vector has been computed. And using this knowledge, you try to train your classifiers, whether it is neural network, it is Bayes classifier, it is a support vector machine or whatever it is. And this is something which is very similar to what we do. Coming to our the first example, when you are shown the image of a cave painting, Ajanta cave painting, it was also told that it was Ajanta cave painting. So I knew what that object is or what that image is. So in the same manner, you train your machine learning algorithms. But the feature vectors are pre-computed by some pre-processing modules. In deep learning, what we do is, no, I will not have a pre-processing module. I will directly input the raw signal to our machine learning algorithm. So the machine learning algorithm will not only learn the classes, it will also learn which feature to look for. And usually, all the machine learning, deep learning algorithms that we will be talking about, they are all neural networks. So effectively, what you are doing is you are adding additional layers in your neural network to learn the features as well. So typically, that is the difference between your traditional machine learning and the deep learning algorithms. Now, there are two types of deep learning algorithms. One is discriminative learning, one is generative learning. In case of discriminative learning, what you try to do is, once you are shown a set of images or set of objects, you try to discriminate among those objects. That means, given the image of a dog, I try to say that it is a dog, it is not a cat, right? So basically, as I said, that every image or every object, if I represent as a point distribution given by Px, in case of discriminative learning or discriminative model, given this distribution x, Px, and given the set of classes say y, I try to find out what is the a posteriori probability P of y given x. That is, given an input, what is the probability that it belongs to certain class. That is what is discriminative model. In case of generative model, it is motivated by what was told by Richard Feynman, that what I cannot create, I do not understand. That is, it is not only that you will be able to classify or discriminate, you should also be able to recreate what you learn, and that is what is your generative model. So how do you do this? You collect a large amount of data in the same domain and then train a model to generate data like it. We'll also talk about this in our future lectures. Then what are the challenges in deep learning or the challenges in machine learning? When you look at an object, you can look at object from various angles, and from various angles or various viewing angles, it will appear to be different. So same object can have different views, and from those different views, we have to identify the object or we have to classify the objects. That is one of the challenges. They may be available in different poses. There may be illumination variation. There may be interclass variation. Say, for example, here, who will say that this is a chair, though all these are chair classes. So I can also have intra-class variation. That is another challenge in this deep learning algorithms, but because our deep learning algorithm has to work even in presence of intra-class variation. There may be distortions and occlusions. Maybe part of the object is visible, the majority of the object is not visible. It might be present in a distorted fashion, and so on. So those are all challenges of the deep learning algorithm. And coming to the power of deep learning techniques, what we can achieve is we can even able to synthesize high resolution images, and this is what is done through generative model. From a low resolution image, we can create super resolution image. Given any sketch of image, any sketch of an object, I can synthesize a photograph of that object. Given a segmented output, I can have a real looking image. So all these are possible using the recent modern deep learning techniques. Similarly, we can also compose videos with different different styles. So all these are possible using modern deep learning techniques, and there are multiple applications like in medical image processing, in object recognition, in speech recognition, and so on. So we'll talk about all these different aspects of these deep learning techniques in subsequent lectures of this course. I hope you'll be able to learn the content of these deep learnings and will be able to apply it in real life problems. Thank you.